In this section, we're going to be working with matched pairs quantitative data, and we want to get a sense of what that might look like first. So let's use an example. Matched pairs study could be the same person in a study getting two different versions and comparing their results. It could be two different people that have a special link, such as, let's say, genetic twins, identical twins. And let's use an example in that sense. We're going to do a medical study, and we're going to have medicine A, and we're going to have medicine B. And we want to compare the two medicines. And so what we did is we first found a set of identical twins that genetically are the same, and we wanted to see how the medication responded to each of them differently. And so we measured, let's say, a red blood cell count on both of these people after taking the different types of medicine. So we had, let's say, one of the twins take medicine A and had a count of 32, and the other twin had a count of 27. Now we go to the next pair of twins, and they were randomly split up between the two different medicines, and the one who received medicine A got a 38, and the one who received medicine B had a 37. Let's do one more example, or one more potential pair of twins. First one had a 29, second one had a 33. And so when you're dealing with matched pairs data, because there's a special link that connects the two patients in the study, the two subjects in the study, we don't actually care about either of their individual results. What we care about is the difference. So you're always going to be working with a single list of differences. So we're going to, instead of having medicine A or medicine B, we are going to, for each matched pair, which could be for each person if it's the same person getting the treatment twice, or for the two different people if it's a pair of twins, for example, you're going to take the difference for them. So in this case, medicine A minus medicine B is going to be our difference. So for the first pair, it's going to be 32 minus 27, and that's going to be 5. So the number we're going to get and care about is 5. Next one is 38 minus 37, so that is 1. For the next one, it is 29 minus 33, and because it ends up being a negative number, you actually keep it that way. It ends up being negative 4. What you're going to see is that if the two twins, or the two versions of the same experiment for the same person, end up having no difference, you would expect to see a lot of zeros in this difference column. Otherwise, you would expect to see a variation of different results. And so that's what the matched pairs data is going to look like. And this data right here is the data that we're going to be entering into StatKey when you do a confidence interval of the difference or a hypothesis test with the difference to see if it is truly different than 0.